Hello YouTube, this is my third video on my module on logarithmic things, but we're going to focus in this one very quickly on what we refer to as the one-to-one property of equality in order to solve logarithmic equations, okay? So let's go ahead and start by visiting the one-to-one property of equality. Formerly, we had seen this with exponential things. We say, like, if I had a to the x equals a to the y, the thing was if you had the same bases, then you could necessarily say that that implies that x was the same thing as y. The exponents must be the same. The one-to-one property of equality with logarithmic things kind of is similar. We say if they have the same bases, log base a of x equals log base a of y. If these have the same bases, then we're allowed to say, well, then this implies that x and y must be the same thing because these are the same logs. So what you're taking the logs of, if they're equal, must be the same thing also. We're just going to use this very quickly and kind of highlight what it looks like. But we say in this first example, it's kind of silly, but we say log base 5 of y equals log base 5 of 16. Thing is this, they have the same bases, these two logs are equal, have the same bases. Therefore, we say y must be the same thing as 16. Okay, and we're done actually. And we can plug this back in and check it, but if I were to put a 16 in over here, we'd get log base 5 of 16 equals log base 5 of 16. A little bit more exotic example would be something like this. So now we say log base, well, what's the base here? What's the base? I don't see the base. Oh yes, okay, well this is the common log. So we say log base 10. Okay, so don't forget, if you don't write the base in, it's log base 10, it's a common log. But we say log base 10 of 4 minus 3x is equal to log base 10 of x plus 2. Well, then this must mean this. 4 minus 3x has to be the same person as x plus 2. So let's go ahead and solve this algebra 1 equation. Ooh, I don't want to switch to purple. No, don't do that. Add 3x to the right side, so we get this. 4 equals 4x plus 2. If we were to subtract 2 from both sides, then we get this. So 4x is same thing as 2 constants. So x, it follows that x is 2/4 or a half. I do want to check this, actually. You should always check your solution. So if I plug this back in up here, and I plug it back in up here, what I end up with is this. 3 times a half is 3 halves, so we get 4 minus 3 halves on the left. 4 minus 3 halves. Remember, 4 wholes is the same thing as 8 halves. 8 halves, take away 3 halves, is 5 halves. So we say log of 5 halves on the left. Now on the right side, if we took 2 plus a half, 2 plus a half, that's 2 wholes plus 1 half. That's 4 halves plus 1 half. We would get log of 5 halves equals log of 5 halves. So, I'm not crazy when we say that we found the right answer here. And then last but not least, let's take a look at one that's got maybe like a quadratic expression on the inside of it. But we say log base 3 of x squared plus 4 equals log base 3 of 29. Hey, check this out. They have the same bases. These two logs have the same bases, and they're equal. Therefore, the thing that we're taking the log of, those must be equal. So we say x squared plus 4 is equal to 29. Let's go ahead and solve this. So we'd boot the 4 over to the other side. So we say x squared equals 25, and we get this. Okay, so the square root of this is the square root of this, and since I took the square root, I say plus or minus 5. Okay, so plus or minus 5. Again, we should check our answers, check the solutions. So if I plug this back in up here, we have to plug in both of them, by the way, mind you. There are 2 of them. But we say if I were to plug in the positive 5, I get 5 squared plus 4 is 29. So I'd get log base 3 of 29 equals log base 3 of 29. The question is, does the negative also work? And if I plug in a negative 5 here, negative 5 squared is still positive. 25 plus 4 is 29. So we actually get both solutions to work. So there's 2 answers, just saying. So cheers.